Welcome back to Inspire AI, where we explore how technology is reshaping our world and how we future proof ourselves for what's ahead. I'm your host, Jason McGinty. Today, I'd like you to imagine this. A hurricane is forming in the Atlantic. In the past, predicting its exact path might take days with the wide margins of error. But now, thanks to supercomputers, we can simulate the storm in real time, running millions of scenarios to save lives and guide evacuations with pinpoint accuracy. That's the power of supercomputers. They're not just big machines locked away in government labs. They're shaping medicine, climate science, national security, and yes, artificial intelligence. In this episode, we'll uncover what supercomputers are, how they're being used today, the challenges they face, and most importantly, why they matter to you. So let's get started. Simply put, what exactly is a supercomputer? At its core, it's a computer designed to perform calculations at almost unimaginable speed. While your laptop might handle billions of operations per second, supercomputers operate at scale of quadrillions, which is 15 zeros. And the latest frontier, called exascale computing, reaches quadrillions of calculations every second. That's 18 zeros. But it's not just about raw speed. Supercomputers are built with massive parallel architectures, tens of thousands, sometimes millions of processors, all working together on the same problem. They require entire facilities for cooling and power, specialized chips to handle complex simulations and AI workloads. Here's a few names to give you a sense of their scale and purpose. Frontier, based at Oak Ridge National Lab in the US. It's the world's first exascale computer. Then there's Fugaku in Japan. It became a household name during the COVID-19 pandemic. It simulated how virus droplets spread in public spaces. And then there's Summit, also at Oak Ridge. It was critical in virtually screening billions of molecules in real time. These examples show what makes a computer super. They're not just bigger, faster laptops. They're national scale scientific instruments like particle accelerators or space scopes. And they push the boundaries of what humanity can understand and achieve. So what are they actually doing? Let's take a look at some of the most impactful ways supercomputers are already shaping our world. Like I said, climate and science, right? Back in 2010, the Jaguar supercomputer at Oak Ridge National Lab ran one of the first ultra-detailed climate simulations. The data produced shaped the UN's climate reports, guiding governments on policy and planning. Fast forward to today, and Frontier can model hurricanes, droughts, and sea level rise decades into the future, giving leaders better tools to prepare for disasters and build climate resilience. Then, of course, there's healthcare and medicine, where during the pandemic, Japan's Fugaku supercomputer simulated how COVID droplets spread in crowded spaces, influencing global policies on mask wearing and social distancing. Meanwhile, Oak Ridge's Summit compressed years of drug discovery work into days by screening billions of molecules against the coronavirus, speeding up the search for treatments. And then there's AlphaFold, which used massive computing power to predict protein folding with astonishing accuracy. That solved a 50-year scientific mystery and opened the door to breakthroughs in drug development and biology. On the defense side, the Sequoia supercomputer at Lawrence Livermore National Lab is used to maintain the U.S. nuclear stockpile without live testing, thankfully, making sure weapons remain safe and reliable while staying within international treaties. Supercomputers also test the resilience of cryptographic systems, protecting banking networks and military communications worldwide. And of course, there's AI. Training large models like GPT required clusters of tens of thousands of GPUs, essentially distributed supercomputers working in parallel for weeks. Without high performance computing, generative AI simply wouldn't exist. That's why it's so important. Now, you might be thinking, that's cool for scientists and governments, but what does this mean for me? Here's the connection. Many of the technologies we use every day started in supercomputing labs. Weather apps, autonomous cars, even recommendation engines like Netflix that suggest your next movie, all rely on algorithms first tested at scale using high performance computing. And increasingly, supercomputing is moving into the cloud. Companies like Amazon Web Services, Microsoft Azure, and Google Cloud now offer on-demand high-performance resources. That means startups, universities, and even small businesses can access this once exclusive power. So in short, supercomputing is being democratized. The ripple effect is faster innovation, broader access, and more industries benefiting from breakthroughs once reserved for elite labs. And of course, they come with their challenges. As you can imagine, energy consumption is one of them. These machines require enormous amounts of power, sometimes enough to light a small city. So cooling alone is a massive engineering challenge. That's why there's growing interest in green supercomputing, reducing the environmental footprint of these systems. As you might have guessed it, green supercomputing focuses on reducing the environmental impact of these high-performance computing systems, offering things like energy efficiency, renewable energy sources, advanced cooling technologies. And yes, green supercomputing is increasingly important as the demand of computational power grows. It necessitates a balance of performance and environmental responsibility. Second is hardware bottlenecks. We're hitting physical limits with silicon chips, memory, and data transfer speeds. Each leap forward demands innovation in architecture and materials. And next, there's the looming question of quantum computing. Will quantum machines eventually replace supercomputers? Maybe. But most experts agree we're still years away, if not decades. For now, supercomputers remain the workhorses of discovery. And another milestone is exascale computing. Machines like Frontier, as I mentioned before, have broken that barrier. But the race is on to scale even further. The lofty goals of artificial general intelligence, artificial superintelligence, we're going to need even more scale. Each step in our AI advancement opens new possibilities, from simulating entire ecosystems to training even more advanced AI models. So think about this and think, why should we care? Because the breakthroughs made on supercomputers don't stay in research labs. They ripple into the tools and technologies that shape our daily lives. They're the reason weather forecasts are more accurate. They're the reason new medicines are developed faster. And they're the reason AI is advancing at lightning speed. For students, this means career opportunities in computational science, AI, data-intensive industries. For business leaders, it means access to tools that drive innovation and competitive advantage. And for all of us, it means living in a world where problems that once seemed unsolvable are now at our fingertips. So I want to bring us back down to earth here. Supercomputers are the silent engines behind some of humanity's greatest breakthroughs. They're complex, powerful, and often hidden from view, but their impact touches every part of our lives. The next time you check out the weather, hear about a medical discovery, or use AI to write, code, or learn, remember this: somewhere, a supercomputer made it possible. All right, thanks for joining me on Inspire AI. I'm Jason McGinty, reminding you to stay curious, keep innovating, and always look for ways to future-proof your knowledge.